Welcome back to Mr. Martin's Math Corner. My name is Mr. Martin. We are on 2.3, modeling equations and inequalities. Okay, I gave you guys a little words chart that's going to help us identify the key words that assist in modeling some expressions. Okay, we're going to use one variable to do this, and it's either going to be an equation or an inequality that we're trying to solve, and we're going to go ahead and make sense of those real world scenarios. You guys ask why we do the math all the time. I'm about to show you why we do the math. Okay. All right, let's go ahead and take a look at this series of steps that I have provided to you. The first thing that we want to do is read the problem, and once we do, we'll go ahead and identify that important information. Okay. The next piece that is highly critical is we must define the variable. Okay, we're going to assign a variable, and we want to let the reader know what that variable means by giving some sort of verbal description. Okay, then we go ahead and write our inequality and solve for that variable. But also, sometimes we might need to use that value for the variable to find the solution to other verbal descriptions. And you guys are going to see what I mean here in just a minute. But I want you to write this down. Go ahead and pause the video, get that. But what we want to do is we want to use a single variable for whatever person or thing that is not modeled after something else. Okay, keep that idea of not modeled after something else in mind when we're going ahead and doing these things. All right, let's jump right into our first example. All right, taking a look here, it says that Aaron and Alice are bowling. Alice's score is twice the difference of Aaron's score and 5, and the sum of their scores is 320. We want to find each student's bowling score. Okay, so if we take a look at this, we want to first find our important information. I'm pretty sure that Alice's score is a piece of important information, and the difference of Aaron's score and 5 is there to help us. And then we also have this piece, the sum of their scores is 320. Okay, so going back to that little piece of info that I gave you, to assign the single variable, we want something or someone who is not modeled after somebody else. And when we read this, it says that Alice's score is dependent on Aaron's, right? Hers is twice the difference of Aaron's score. So in this case, Alice is modeled after Aaron, but Aaron is not modeled after anybody else. So we are going to assign Aaron the single variable, and I have this drafted up for you just as a little bit of help. So we're going to let A represent Aaron's score. Okay. Then we know that Alice is going to be the other one, but we needed to know how to write this. How did I come up with this 2 times A minus 5? Well, we know that her score is twice something, so it's going to need that multiplier of 2. And then it says the difference of Aaron's score and 5. So if we're doing that difference, Aaron's score and 5, we need to make sure that we put the variable A first, which is Aaron's score, and then have that difference of 5 come after. Okay. Then it tells us to solve the equation for A. This is Alice, remember? Okay, so let's go ahead and we have the sum of their scores. That means we're adding up Aaron and Alice. So we have this A plus 2 times A minus 5. And we're going to set that equal to 320. Okay, now if you look, we've solved equations like this before. Remember, we need to distribute first. Okay, so now we're going to get A plus 2A minus 10 is equal to 320. We combine our like terms, we get 3A minus 10 equals 320. We're going to add this 10 to both sides. We get 3A equals 330. And then when we divide both sides by the 3, we're going to get A is equal to 110. So if you look, we found the solution for A, which is Aaron's score, so we know that Aaron has a score of 110, okay? But now we need to use this value in our other expression so that we can find out what Alice's score, because Alice is modeled using 2 times A minus 5. So we just simply plug in that 110. Remember, we always substitute using parentheses. and we're going to get 110 minus 5, which is 105, multiplied by this 2 will give us 210. So we have Alice's score as 210. And if you want to double check, we know that the sum of them equals 320. If we were to add these two up, we would indeed get 320. So that is it for us. That is a wrap. 110 and 210. Very good. All right, let's take a look at the next example. So here we got Marie, Carlos, and Amanda collect stamps. Carlos has 5 more stamps than Marie, and Amanda has 3 times as many stamps as Carlos. Altogether, they have 100 stamps. We want to find the number of stamps that each person has. Let me go ahead and slide this down a little bit so we can see our work. Okay. The first thing we might want to do is we might want to write down what our variable is. So here we're going to let S equal stamps. Okay. And then we might want to figure out how we're going to model each expression for these 3 names. So let's go ahead and pop their names in. Alright, so I got my names up here. Appeared out of thin air like magic. Alright, let's take a look. We want to find our important information. We got a piece right here. Carlos has 5 more stamps than Marie. We also have Amanda has 3 times as many stamps as Carlos. And then we also have all together they have 100 stamps. So let's find out who is being modeled after who. Well, Carlos has 5 more than Marie, so Carlos is being modeled after Marie, and Amanda has 3 times as many as Carlos. So Amanda is modeled after Carlos. So it looks like Marie is not modeled after anybody, so Marie will be our single variable S. And we take a look again at our problem. Carlos has 5 more than Marie. So if we have Marie's amount plus the 5 more, we can get what Carlos has. And then now Amanda has 3 times as many stamps as Carlos. So if Carlos is Marie plus 5, right, S plus 5, let's make that look like an S. We want 3 times as many as that. All right, very good. We got all 3 modeled. We know that all together means the sum. We want to add these up. Let's go ahead and do that here. So we got S plus 5 plus 3 times S plus 5. And this is going to be all together to equal 100. Go ahead and do your distribution. Okay, we're going to get S plus 5 plus 3S plus 15. Alright, very good. Remember, we always combine like terms. How many S's do I got? 1, 2, 3, 4, 5. 5 S's. 5 plus 15 gives me 20. That's equal to this 100. We subtract our 20s. Then we get 5S equals 80. And we divide both sides by 5. We're going to get S is equal to 16. Okay? So let's go ahead and start writing in our solutions. We know we found S, which is Marie. So Marie has, Marie has 16 stamps. Okay, let me go ahead and move this over for us. Whoops. Alright, I got that moved over for us. Now we need to use this solution here, okay, this 16 to find out what Carlos is. So if we were to substitute that 16 for S, we get 16 plus 5, which is equal to 21. And then down here, we want to sub that in again. We get 16 plus 5. 16 plus 5 is 21. 21 times our 3 is going to equal 63. Okay, so now we found out what Carlos is. Remember, we will always want to label what our solutions mean. So Carlos has 21 stamps and Amanda has 63 stamps. And together, if we add these up, it's going to look like our 100 stamps. All right, I want you guys to try the next one on your own. Remember, pause the video, come back, and see if you got the same thing I did. All right, welcome back. So hopefully you got the same thing I did. I went ahead and put down the formula for my perimeter. It says that the garden is 8 feet longer, so the length is being modeled after the width, so I assign that single variable. And then we know that the length is 8 more than the width. We plug those in, we find the width, which is 60, then we use that value back inside the expression for the length, and we get that 68 feet. All right, very good. Let's look at example number 3. Okay, this one's going to be a little bit different than the previous ones. We need to take a look at our important information. All right, Janine has job offers at 2 companies. One company offers a starting salary with a raise of $3,000 each year. Remember that each means multiply. Okay, and the other piece is we have a starting salary of $36,000 and a raise of $2,000 each year. Okay. What is the question asking us? Let's scroll down here. It asks, in how many years would Janine's salary be the same with both company? Okay, the first thing we want to do is define our variable. Bam. All right, we want to call y. We're going to set y for years. Y is equal to years. Now let's take a look. We have a starting salary, something that we start with, right? I can't even talk today. A starting salary is something that we start with. Okay, so we're going to do 28,000. And then we know we're getting on top of that. If we're getting something on top of that, we want to add that, right? So we're getting 3,000 per each year. So we're going to have 3,000 times however many years we got. And it wants to know when would it be the same. The same means equal. So we're just going to set up this other side. Let me do that in green for you. We got 36,000 plus our 2,000 each year. Okay, and now it looks like we just got one of those multi-step equations where the variable is on both sides. We just need to get that to one side, so let's go ahead and do that. So I'm going to subtract this 2,000y from both sides. That's going to give me 28,000 plus 1,000y is equal to 36,000. Okay, then we minus the 28 from both sides. And we get 1,000y is equal to 8,000. We're going to divide both, we're going to divide both sides by 1,000. And we're going to get y is equal to 8. So in 8 years, right? Remember, we solved for y, and y means years. In 8 years, it indicates that they are the same. So if they are the same in 8 years, what is that actual salary going to be? There's our next question. We know that this expression is equal to this one, so we can actually plug that 8 years into either one of these sides. I'm just going to do it to that first one here. We would have 28,000 plus 3,000 times our 8. That's going to give me 28,000 plus 24,000. Whoops. We got 24,000. And then when we add these up, we're going to get a nice big number of 52,000. And remember, that is dollars. Please make sure you label. So $52,000. Not bad for a fiscal year. All right. Let's take a look at the next one. Up, it says you try. All right, you go ahead and do this. Pause that video, come back. Let's see what you got. All right, welcome back. Hopefully you got what I got. I ended up with 16 hours. And then when I plug that 16 into actually one of the two expressions, I get $1,056. Don't forget to put that $sign. All right, I got another one for you to try on your own. Go ahead and pause the video here. Remember, we already talked about perimeter. You know what the formula is. We add up all the sides. You guys go ahead and do this one. All right, great job. Welcome back. So I ended up with 28 feet of fencing. Remember, I just added up all sides of the triangle. Then I used the 2w plus 2l for this rectangle. Okay, after I simplified everything, distributing and combining like terms, I get 6x minus 2 equals 8x minus 12. We saw for x, we got that 5. And then remember, you can plug it in on either side and you should get 28 feet. All right, very good. Let's look at our next example. All right, this one is a little tricky, so make sure you pay attention. We start off with our important piece of information right here. Kim works 4 hours more each day than Jill does, okay? And Jack works 2 hours less each day than Jill does. All right, so let's see, who is modeled after who? So Kim is modeled after Jill, okay? And then Jack is also modeled after Jill. So we will assign our single variable to Jill. We're talking about hours, so let's do H equals hours. Okay. Kim is 4 hours more than Jill, so we got Jill's hours plus that 4 hours more, and Jack is 2 hours less. Okay, but the unique part about this is they don't want us to find that out yet for just one day. They said over the course of 2 days, then they gave us this information. Okay, so if we know that we're doing something for 1 day, but we're doing it for 2 days, right, that is kind of like an each or an every, we're thinking about doing some sort of multiplication. Okay, so the course over 2 days, we are going to multiply each person's hours of 1 day by 2. Okay, so we're going to get 2 times h plus 4, which, let's work this out, is 2h plus 8. 2 times h is just going to be straight up 2h. And then we have 2 times h minus 2, which gives us 2h minus 4. Okay, now we have these nice good expressions of the hours worked over 2 days. Let's go back and read what it says. So it says the number of hours Kim worked. So where's Kim? All right, she's the 2h plus 8. Is equal to the difference of, okay, so we got two different pieces. We got the difference of, let's find the first one, 4 times what Jack worked. Okay, where's Jack? We need 4 times that. Okay, so we got 4 times what Jack worked, which is the 2h minus 4. And it's the difference of this and the number that Jill worked. So Jill worked 2h. So we got this minus 2h. All right, let's go ahead and solve this out. We get 2h plus 8 equals 8h minus 16 minus 2h. We got like terms right here. That's going to give me a 6h minus 16. And then on our left side, we still got the 2h plus 8. Let's go ahead and subtract this 2h. We're going to get 8 is equal to 4h minus 16. We add the 16 to both sides. We get 24 is equal to 4h. Then we divide both sides by this 4. And h is going to be 6. Okay, so we found out what h is, but we have these 3 different expressions that we need to plug this into. So we're going to have, for Kim, we're going to do 6 plus 4 is equal to 10. We have just the 6 for Jill, which is equal to 6. And then we have the 6 minus 2, which is equal to 4. So Kim is equal to 4 hours. Jill is equal to 6 hours. And Jack is equal to 4 hours. Whoops. Let's change this. Not 4 hours for Kim. I apologize. That is 10 hours. 10 hours for Kim. All right, I want you guys to try the next one on your own. Go ahead and pause the video here. This one is just like the one that I showed you. Find who is modeled after who, and then give that single variable to someone that is not modeled after somebody else. All right, pause the video here and see what you get. All right, great work. Welcome back. So what I found out was that Lisa was modeled after Ian and Ian was modeled after Jim. Okay, one of the parts that you had to figure out was in 7 months, they each increased by 2 centimeters. So 2 centimeters each month would be an increase of 14 centimeters. So after I modeled, I added 14 centimeters to each person to get these three expressions right here. And then Ian and Jim together were equal to Lisa plus this 170. So we found our value for H, and we wanted to know Ian's height right now. So we use the right now expression. We plug that 166 in. We add that 14. We get Ian is 180 centimeters. All right, very good. Okay, now we have example number 5. So we want to ask ourselves, what is different with example number 5? All right, let's check this out. We got Elisa. She won 40 lollipops. Okay, that's pretty important. She gave 2 to every student in her math class. And then she has at least, look at that word least. That is going to indicate an inequality, my friends. What color can I use here? Let's use yellow. So she has at least 8 lollipops left. So now we're going to be using an inequality to model. We still need to write down our variable. So let's see, what are we going to let our variable be? All right, so we're going to use S for students. Okay, so let's go ahead and set this up. So we know that she started with 40 lollipops. Okay, if we're starting with 40 lollipops, but then she's giving 2 away to each student. So that means we're going to be taking away however many lollipops, and it is 2 per student. So we're going to use 2 times S. And here's the trick. If we need at least 8 lollipops left, okay, that means we can have 8 being the very least. We could have 9, we could have 10. So if we're making those numbers go up, we want to be greater than or equal to. All right, so that is our inequality to represent that variable. We defined it. We used S for students. Now we want to solve and figure out what is the maximum number of students we can have. So let's go ahead and solve this out. We're going to subtract this 40 from both sides. Okay. Minus 40. Okay, that gives me a negative 2s greater than or equal to 8. Look at this, we're dividing both sides by a negative. That means we need to flip this sign. So the amount of students is going to be less than or equal to, oops, that's not an 8. That should be a negative 32. Negative 32 divided by negative 2 would be a positive 16. So max students is 16. If she has any more than 16, she would not have 8 lollipops left. Okay, so we model the same way as we do with equations. We are just doing it with an inequality sign, and you just need to figure out which direction your inequality sign will go, and also if it will be an inclusive or an exclusive. All right, I got 2 more examples. I want you guys to actually try these on your own. Let's go ahead and pull that up. Pause the video here and then see what you can come up with. All right, welcome back. So I used the variable C to represent the cost of the composition book. Let's put that in actually. Cost of comp book. Okay, we know that they bought 5 of the composition books, Bill did, and then the cost of the magazine is 40 cents less than the cost of the composition book. So we have 5 of these. He only bought 1 of the magazines. And when we crunch this out, we get C is less than 440. Remember, he spent less than 26. He could not spend 26 even. He had to spend less than 26. That is why I did not include that underline. And then I got $4.40 is the max cost to be under that $26. All right, here is the last one. I'm going to pull this up. Let's slide this down. I want you guys to try this one and then come check it out, and we'll close this up. This will be a wrap. All right, welcome back. This is our final one. We put down H for hours. Our inequality is $2 per hour. That's how we got the 2H, plus this $10 fee, and she spent less than $27. So whatever we're adding up as her spending has to be less than this $27. After we crunch this out, we get 8.5. And the reason I got two answers here is because two answers would be acceptable. We don't have enough information quite yet, but the total to be less than 27 for the max amount of hours is 8.5 hours. Okay, so if this company lets you rent by the half hour, then we could definitely use 8.5 hours. But if it is only by the hour and she wants to pay less than this $27, then the most amount of hours that she could do would be 8, and that's only if we're counting full hours. So either one of these would be acceptable. You can definitely argue the reasoning, but we are done. This was modeling equations. I know it was a lengthy video, my apologies, but these do take a little bit longer than our traditional problems. So go back through this. Remember, if there's something you didn't understand, take a look at it again. Ask a family member, ask a friend, ask a teacher. We are here to help you. Thanks for watching this video. Again, my name is Mr. Martin. I will catch you on the next one. Peace.